the field, effective water pollution prevention in practice. So what I'm going to do again today is talk about a little bit about technology and things that can be done to improve water pollution. Myself as a business and us as a business, we believe that there's no excuse for actually having any sort of discharge into controlled waters. It can be done. It can be controlled. There's lots of companies out there doing it right now. So it's trying to pass on a little bit of information that we've done and hopefully allow you to sort of think about your particular industries or whatever you're into, your own passion. If it's not necessarily in the industry we're in, it might just show you some of the things that are going on and give you a bit of encouragement. So a little bit about me. I'm repeating again. Obviously, if you've seen this before, you'll know a little bit about me. My background is as a time-served craftsman with Ford Motor Company. In that time, I started in 1980, but I became maintenance sort of fitter. In that time, we used to have a lot of pollution incidents. So I invented a product called EnviroValve in 1998. Simple inflatable bladder system. Lots of people now sort of copy it and do the same. What it was just something that when we had an incident, I could block a drain and use the drain really as a containment area. I can remember back in the 1998 speaking to somebody at the EA, quite senior, who thought I was completely nuts because everything was about stopping everything going in the drain. My process was, but everything aims for the drain because it's gravity. So let's use what we've got and make that a better structure. I think it worked. You also they've got a product which is a portable product with the fire brigade. The EA actually asked me to design this with the fire brigade, which is a portable bit of kit. It's branded under EnviroValve, but Drain Block is a product that now I've actually improved on, but the fire brigade still use that today. APA awards, the Fuel Industry Awards, we've obviously done some work with the designs of valves. Most importantly for me, and it was a great privilege that the Environment Agency asked me to join the writing of Syria 736 and acted as the launch speaker. This is all to do with Bunsfield, and this is to do with tertiary containment, firewater containment, bund designs. My focus, as it will be today, is all about the tertiary. I'm a strong believer that most pollution incidents that get into controlled water are a failure of the tertiary, not the bunds. The bunds may fail, but the actual route, the pathway for pollution is via the tertiary. So a little bit about who we work for. We've done some projects for all these companies, all different degrees, all got different reasons. But to me, they're all quite big name companies, but they show what sort of companies are out there looking and actually are very interested in this subject. They don't want pollution. They don't want it to happen. Sometimes there's a little bit of ignorance because you get local level. People don't understand how to control a spill. They may not actually know they've got a spill kit, but not how to use it. We try to look at that, work with these companies to devise a simple plan. So, right, we're back on track now, hopefully. So the first sort of case study that I want to talk about today is going to be Toyota. Then I'll look at some Marshall's Aerospace, Ford Motor Company, and a project we did for Marks and Spencer's. All these are current projects or jobs that are completed and been running for several years. Some of them have just been finished. But here we go. So I'll start now with our first one today, which is all about automation, obviously, is Toyota. So we're looking at Toyota. This is their site up in Deeside. Now, most car industries are quite up to speed with environmental controls. They're a big branded name company, so they're quite proactive, and they certainly don't want to be dragged through the courts and get their brands damaged by a pollution incident. So they're always proactive, and they're always good companies to work for. Good to have a chat with as well, and we gain ideas. So what we've done here with Toyota, they had a pollution exercise. So they've already got fire, water, and pollution containment in place. They'll have spill kit training, spill kits everywhere, but they've also got isolation valves on their drainage network. Now, following a pollution exercise, part of their environmental management system, it failed to meet the company's standard requirements, which was actually to contain. So what they wanted to do is how would we contain a pollution event quickly? What they found out was basically the system that they had installed and running took them 45 minutes to actually operate. Now, anybody knowing a pollution incident would know that that isn't really quick enough. Also, it was a manually operated, so they had to manually go around the site and apply pieces of kit and close drainage penstock valves. If that site was on fire, the last thing that would be happening on that plant would be people walking around aimlessly around the factory trying to close valves in the middle of yard areas. It didn't work, so it highlighted that they need to do something about it. So there you can see is a standard penstock valve, quite common inside a nice little catch pit. Really good job. What you've got here is this is one from that particular location. It's a 700 penstock valve, drops down. The flow is hitting it in the what we call the on-seating position. Perfect. What it doesn't do, though, is it doesn't stop the flow as you've got just a trickle, which is how a spill actually occurs. So it'll be just a trickle. It'll even be a trickle when we've got firewater runoff, when it's running through all the drainage networks. So what you end up getting is far less containment because you don't get this valve filling up because the water going through just passes through the bottom, through the gaps, through the sides. Yes, you can adjust the stoppers and get some sort of control, but you're never going to get a full containment on that valve. Other part to it is you've got to operate this one by hand. So what the site was initially looking at is, how do we automate that valve? How can we actually get around to making that valve be automated? That was the first challenge we were given. My challenge obviously then was to say, it's pointless is actually automating a valve unless we actually prove that it stops the flow. This valve didn't stop the flow. It slowed the flow, and it would have stopped probably if there was a good head of water. But under normal conditions, spill conditions, it didn't really have much effect. It just creeps through, seeped through onto the gaps, even though we've obviously adjusted the stoppers to try and get a better clamp. So the challenge to us there, I've just really covered it, was to take the existing valves and make them automated. When we do that, you've got to look at speed of activation. You've also got to look at the mains power. There's no point putting a valve that's used for firewater containment or pollution containment and running it off the mains and not having backup power. So that needs to come from, we need to facilitate the fact that if that piece of equipment being safety critical, we have a fire on site or we have a power cut on site, is that valve needs to stay operative. There's quite a lot of businesses out there that have manually operated penstock valves. There is no way you could operate one of those in a disaster. By the time you get to it, the disaster has probably passed through the drainage network, certainly. They're not thought about. You've got to lift manhole covers. There's a handling issue. When you go to mains power, what you've got to look at here is, if you've got mains power, this system here is, if you lose mains power, that valve doesn't operate. So you've got to come offline. So fine to be mains power, but it must have some sort of battery backup or some sort of mains power off your battery support. And it's got to have some sort of control where somebody can operate it. There's no point in people having to walk around a whole site trying to operate a valve in a major disaster. The fire brigade is going to take control and remove people. The Toyota site there, certainly, as it's got a foundry involved, would definitely be people away. They wouldn't be allowing people to go wandering around a site to operate a valve. Not even the fire brigade, I don't think, would want to enter certain areas. So what you got there is, that's what's the sort of setup you get. This is a standard setup. You've got a nice little catch bit. Good job. There's nothing wrong with it. But I first of all questioned that valve actually would be activated in time of an incident. But certainly, does it actually stop the flow? Probably that type of penstock valve, you've got a reasonable to stop a very heavy flow, flood flows, but certainly not a very light pollution flow. It'll just pass through the bottom and through the sides. So what did we do? We ended up, cost-wise really, was we replaced all the existing valves with solar-powered toggle block valves, which some of you may know about our valves, and I'll show a little bit in a minute. So this is using the air-activated systems, nice and simple. I'll show you some images in a second. The valves were automatically triggered, therefore, from the fire alarm. So they link into the fire alarm, a little monitoring station that we put in the size of a mobile phone, to be honest. So it's not a big piece of kit. It's very, very simple. And the activation time was reduced from 45 seconds to under 15 seconds. That's what you need to do. There's no human beings now having to go around and operate these valves. At the end of the day, it's human safety first in the event of a disaster. What we're looking at, we don't want people running around trying to apply bits of spill guards, etc. Let's contain it in the very thing that we've got that actually will contain huge volumes of water. But let's just make sure that the design it's actually working. If we can apply for small spills, the spill kits and the equipment you've got, that's fantastic. But that's more of a reactive. This needs to be done at the event of that incident to stop that final release, because that's the thing that's going to cause your prosecution. So what we've also done with the system we've got there is reporting to key personnel. So if ever a valve closes, it communicates using a smartphone to actually say, I've been activated. That also then gives them a log to actually see whether the valve closed, whether the valve opened. So I think any system that you're designing, whether you're using our product or not, you need to be thinking of those key points. Is if you're going to make it mains powered, it's got to have some sort of backup. There's no point in putting a safety critical piece of equipment in and wiring up to the mains power and then being a major power cut, which is when there's a good chance you might have an overfilling tank or etc. failure of equipment, and the valves you've actually put in, you can't operate them. If you've got penstocks and you've ever tried to turn a 600mm penstock down or up, you'll find it hard work, and you certainly wouldn't do it quickly. So there's the system that actually is in one of those sites. That's one of the pieces of kit. Very, very simple. Just literally is on the flow. You see that's got the flow out. So this is actually going to be, again, replacing the penstock directly on seating. It'll just drop down into the flow and close the flow off. What you can see on the next image here is a control panel. That's a 300 square little box. It's bolted to the existing sort of area, so we haven't had to do much anything really about it. This is turning that, obviously, that manual valve now into an automated valve. That little tiny box is controlling that huge valve, little tiny 10-watt solar panel. And on your right is what we call our RACP, Remote Activated Call Point. What it means is you can actually operate up to 8 valves off a single remote control device. This device here is using GSM, so it's using the mobile phone networks. Obviously, you can do it off radios. The beauty of mobile phone networks is, it's good coverage. You can normally get around most sites. You haven't got to worry about line of sight. but also it gives us good feedback. So we get information whether the batteries are low or whether the valve opened, whether the valve closed. And these are really key things because a lot of sites we visit, they've got a system that tells them that the valve operated, but didn't necessarily tell them that the valve actually closed. It just operated. And it's key here is the valve. If the valve doesn't close, we need to know. Should be able to just give you a little image if any of you've seen it before. There's a bit of a whistle, but that's the alarm to actually say that's activation, because these are remote operated valves. So if you're in a remote location, somebody needs to hear this sound to actually know that something's happened. Hopefully alert you to the equipment being activated. And now the valve will just open. So this is just resetting. What you got is the flow is hitting that flap. What you probably notice is if there was a heavy head, we'd had a really good fire or a good pollution event and somebody opened that valve, it's not going to release the water straight away. The idea really is if you operate these valves, these are not Penstock valves. A Penstock valve is a flow control device. These are isolation valves. So perfect if you've got a flooding issue or perfect if you've got a pollution issue. They are stopping the flow getting in the direction that you want it to stop. The thing that you must remember is that these are used for a safety critical piece of equipment. Nice and quick, using pneumatics and air, so we've got nice intrinsically safe. We've actually rated these up to a SIL level of 1, so that's nice and simple piece of equipment. Excuse me. So now what I'll move on to is Marshall. So this is quite a common thing that we get with quite a lot of sites, and there's Marks and Spencer's later, is sites been told that they need to, for their permits, need to carry out some sort of monitoring. And a lot of sites do that by doing dip tests. So they're doing a dip test daily, weekly, whatever it is. And this is basically just to confirm that everything is okay. To me, really, I never quite work out how that works, because I could literally go, it's the same as driving your car. Well, the tires are okay now, but it still doesn't mean you're not going to get a puncture in the next 30 seconds. If you do a dip test, it's okay when you did the dip test. It certainly doesn't mean that you're okay after you've walked away. So really, you've got to have any sort of water discharge where you've got a risk. It's got to be live monitoring. So that's what we would really look at, is if we're going live monitoring, how do we react to that live monitoring? There's no point in having a live alarm that goes, we've got a high alarm or the pump's failed, and we can't actually do anything about it. I think this is where the water industry fails. They've got high alarms that say pumps fail. These pumps fail, the sites just flood and then dump all the effluent straight into the rivers. And when we've got major pollution, it's because there's no ability to actually do anything about it. So what you've got here is a nice little attenuation pond, settlement pond, where we like to call it. Quite common on sites where they're looking at controlling a certain flow. So what we hear is where you can see this head wall, that's where we monitor the pH. That's where we're going to take a pH measurement from this pond on the outfall. That's the outfall there. That's what's obviously built. What we're looking at is how to monitor that. That goes into alarm, shut that flow off so that flow can't get out. And then the site can do something about it. The beauty of this is mainly it's about holding the material and allowing nature, the sunlight, to naturally break down the pollutants. So we're looking at implementing a real-time monitoring, balancing the pond, provide an automated shut-off in the event, and that's going to be, I'm afraid with us, it's going to be toggle blocks. It's the easiest thing, a bit of kick. Remember, we've got no power out to some of these areas. Luckily, at this site, we do have a bit of power. Allow a remote activation of the valves in the event of emergency. So what we're looking at here is a control tower operation. So that if there was a fire, an incident on the site, that you can actually activate these valves without going to them. Again, this one here is done by an M2M system. Excuse me. And what we can do is we can actually control from anywhere in that site. They can operate those valves and report back. Key is if you've done something, if something's happened, I want to know why. So what we've done here is this is a Chemtech pH system, off the shelf. You know, these are systems that sites are already using. This one is mains powered. We have got mains power to this site, but what would normally happen is this was put in. We're monitoring the pH, great. We're logging the pH. All we're really doing for the regulator and the water company, etc., is saying we had a problem last Thursday. You can fine us. What we want to do is say we had a problem last Thursday, but nothing left the site, because the minute that went outside of its consent, we shut the drain. And that's what we're doing. That's the simple idea. So we've installed this pH monitor, which is logging, which is giving the site its logging information. So they're able to put their memory stick in and log all the data from past records, which satisfies the regulator. Every time this valve, though, is operated, it closes off the pond. So if we get a high pH, the first thing it will do is shut those valves. The first thing that those valves will do is report to site that they've closed. They'll report that there is an incident, there is a problem, which means somebody can get out to that incident and actually deal with it quicker. We're not just waiting and, oh, well, I dipped it on Friday, and we found out once the EO said there's a load of dead fish that, we had got a problem, but nobody spotted it. This is literally there and then. This is within seconds. I think we've got about a 5-second delay on that pH. If that pH sees an alarm for 5 seconds, it will trigger. Nice and simple. It's set up automated activation linked to the pH monitors. It's turned a standard pH monitor, which you could turn this into an oil interceptor alarm. It could be anything you like, a turbidity sensor, a tox sensor. You've turned a standard alarm system instantly into something that's giving you data, and that then can go into a web hub. So you can actually make this into a nice BMS front page. You can actually see what's happening live, and that's how this simple. It's really simple. You're not using complicated equipment. There's very little power. There's very little problem. This is a 2-day installation. The other thing we've got is obviously using that little RACP that we make is you've now got some sort of automation from key points. They can have as many of those as they like. It'll operate up to 8 valves, and each one, when somebody presses it, it will communicate to key staff which automation valve was obviously triggered, so they know where and who obviously operated it. So what we've got there to me is you've now got something you can present to the regulator. You can present to whoever you need to say, we no longer just have we're in tolerance now. This is constantly monitoring, always nice and simple, standard piece of equipment that anybody can buy from any of you. Got what we've got there is the Kerry Tech, but you could use any pH so long as it's got an alarm output. So here's a bit of kit we got here. You'll see we've got a pH that's on a boom there, just out. You've got the valve that sits there now, nice and simple. So, and a little solar panel, which is running our control panel. We keep the valves really with solar because we don't need to run them on mains. We can if we want to, but we don't need to because they need to be on all the time. The idea is if the pH on here actually do get a power cut on site, these valves shut automatically anyway because the pH will naturally go into alarm. So we've also got the added thing that if the site did have some sort of catastrophic failure, is what we'll do is we'll stop flow, which I think is the most important point. Another one here now is Full Boat Company. It's slightly ambiguous, really, because it's a Full Boat Company. It's actually a car showroom. Now, what you've got here is it's a sensitive area down in Dover. So you've got quite a sensitive area to the Environment Agency with the water, the potential of risk. Building a brand new car showroom. So you wouldn't normally associate that sort of industry with pollution risk, but they do have them. And so I've just put out a little map just to show you. I'm sure there's people here that know that area quite well and know how bad it is. But what they've got is on their building, they've been had to fit some sort of pollution containment after the oil separator. Now, oil separators do have their own closure devices, not that reliable, and you've got to maintain them. The idea here is something really simple that can connect into the oil interceptor alarm and trigger the valves. So the challenge to us really is to satisfy, if I remember this one, was to satisfy the Environment Agency and planning authorities, because they weren't going to give any planning permission or wouldn't allow the building to go through unless they could show that they could safely contain any form of pollution, specifically oils, I think, and cleaning products around the garage maintenance area. You know, small little business, but they can cause a significant amount of damage if the environment is sensitive. So what you got there is we use a lot of Euro gauge, nice bit of kit, really like them. Dead simple. We link that into the oil interceptor alarm, so that's the oil interceptor alarms we use. And we link that into our piece of RACP as well. So we've got a fire containment plan, and we've also got a basic oil interceptor, high oil alarm, triggers the valve to shut. There's nothing much more simple than that. The top block is fitted on the waterfall outlet, so we put a nice little chamber. It's linking to the oil separate alarm, automatic activation, and it provides a remote operated control in the workshop. So the workshop as well has, if they do have an incident, they can close the valve. And it's working really well. This system is with, to be honest, a car showroom isn't normally with people that would normally operate our valves. The staff find it really easy. It's just 2 buttons, and they get an indication of what the valve position is. It's not really anything that they need to worry about too much. So it's working really well, and it's open. So all I can say is the Environment Agency must have approved the design and what we put into place. So here you can actually see the installation that they've got. So there's a nice valve. This is pre any water going through it, because this is as we finish the job. Nice simple valve. The flow is obviously going through the valve. So again, the valve is being pushed shut by the water when we close it. And the nice little control box inside the workshop area. This is actually a mains powered plugged in one. So this is using mains power. If we lose mains power, we've got battery on it as well. So it's always running on the battery if it loses power. And the system will run for about a month without any solar or any mains power. So you're not going to really worry too much, and it will signal you to let you know that it's got a low battery power. It's also indicating that position of that valve. So here's another one that we've got now, a final one really, which is a much more complicated one, but I think quite interesting because this is Marks and Spencer's. So they'd taken an old logistics park. I think it may have been one of their own existing sites, but they turned it into cold storage. So you've got a lot of pollutants around that. You've got a lot of milks and products. They also put a vehicle refueling station in, brand new one. So, and it's based down in Enfield. So what you've got at Enfield, you've got the navigation, which creates a bit of concern over pollution. Obviously, you've got a reservoir on the other side as well. So it's quite a high risk area. And what you've got is on the consent is that the EA is looking for some sort of control to issue them with new environmental permits. To be honest, as soon as a business looks at changing their permits or applying for a new permit, because of the changes in technology that are out there now, is the Environment Agency are clearly in the right place to actually ask to say, well, you might have just had a couple of drain mats before, but really now we need to see that you can actually control a disaster. And that means going back to the Syria guidance that I've talked about before. Syria 736 is actually understanding what actually happens when you have a major incident. So I've got a little image there of the site. You can see the River Lee navigation. You've also got a reservoir also over here. But you can see here is what they've got is a huge attenuation system. So what you've got, a lot of these sites, especially the Enfield and London area, is quite a big catchment area. It all runs into huge attenuation tanks in this grassed area. Those attenuation tanks then are pumped into a receiving chamber. That receiving chamber then moves into another oil separator and then out across into the river. Now, what we're looking at is, could we therefore, in the event of any form of incident, which is shut this site down? That's linking then a little bit more complicated. So we're looking at, well, if we've got pumps, we'll need to isolate the pumps. If we have a high alarm, we need to control it. So the challenge is provide real-time monitoring again to satisfy the Environment Agency. We went for a TOC system, total organic carbon. So it's a real all singing, all dancing bit of kit. We got that from PPM, who obviously installed it, and we've worked with them quite well on it. They look after that piece of equipment. Far too technical for me. But what that's doing is that's constantly monitoring, so it's looking for the organics at all times. And what that does is that links then into a toggle block system and to an alarm system. So it provides the key staff with information. So if they have a power failure on the site, the valve shuts, the alarm system goes off. If they have any hydrocarbons present, if they have anything that the TOC system's pH as well goes off, the valves will close, and it will literally lock the system down, but it will also report to them. They've also then got activation points on the fuel island, which means that they can operate the valve quite a distance away, which will shut down. They've also got a security office, which has actually got control of the valves as well. When we close this site down, it also needs to link into the pump stations because the pumps need to turn off. What you've got there then is quite a relatively low risk site in what it does because it's not manufacturing as such, but it is constantly monitoring. I mean, we've had a couple of incidents on there, never a pollution incidents. The incidents about we've picked up some vegetation that actually the TOC sampler has picked up and caused an alarm to go off. We actually had one once when we had a pump fail. So the pump failed and that triggered the valve to go off. But it does actually help because it alerts everybody that something's gone wrong. Whereas normally with standard equipment, if it hasn't been automated, it fails and nobody seems to know until it's too late, or something actually then, we've got a bit of flooding, so something must have gone wrong. So what we've done is we've fitted the valves. I've just said top monitors, all present reporting to a cloud. I've got a little bit about that we've done. And this is going back now with the systems we've got that are reporting back into this, this cloud-based system. So here you go. It's a nice bit of kit that we've got now. What you've got here is you've got a top monitor. And this is obviously running. You've got the pH here. Somebody just say my sound's going, but I'm not quite sure why. So I might have a little bit of issue with the sound. I can't really do anything about that, but I'll just keep plugging on so you can see the images. What you got here is a TOC sampler. You've got the pH monitor. You've got an oil separator alarm, interceptor that controls it, and you've got our valve now in the catch pit. Here you can see the pumps running off. And this is now what we're linking into. So what we are is we're monitoring the actual site's levels. So what we do is we're controlling. We know the gully status is open and closed. We know that the remote triggers, the remote triggers are okay. And you see here, there's an alarm message. This is the TOC sensor. This is saying that we've got a high reading, not necessarily going to close the valve, but it's something they need to go and look at. It's actually a dummy screen, to be honest, but it's what it's doing. It's giving us information to present what we've got. So that's it today. I understand we've had a bit of sound issues, which is really frustrating. I'm going to have to get in touch with our IT guys to sort out why my laptop keeps dropping out. I hope it's been interesting. Please get in touch. You can also join me on LinkedIn, because I put a lot of stories and a lot of information out there on LinkedIn, which I'm sure you'll find interesting. It's more about getting people engaged in this subject. Yes, we make a valve that's really good for containing and stopping flow, but it's actually making people start to think, well, if we've actually got a piece of equipment, does it actually work? And we want you to try it and make sure it works. There's no point in buying equipment and having penstock valves or having a system in place if it doesn't actually do what you think it's going to do. You know, it might just be that your site needs a bit of training on spill kit management, how to actually deal with it. But then when you look at the monitoring side of it, there's loads of monitoring equipment out there that doesn't actually connect to anything. It just says, I'm in alarm, and people turn it off. We want that to be connected into something that makes you do something about it. So yeah, get in touch, go to LinkedIn and get me on there. Hopefully we're going to do one, another one on the 21st of November, and I'll have sorted out any of these problems. If you've got questions, please, because obviously we've had a few issues today, ping us an email, ping Martin or I an email. I'll get back to you. You can also arrange for us to come and do obviously a one-to-one or with your team. Okay, thank you. Goodbye.